So we will continue with the questions number 14. So in the 14 question number we have given integrate cos x minus sin x by 1 plus sin 2x. So how we can do that? It is very simple questions actually. Here we can see it very clearly that denominator part we have given. First I will write the numerator as it is cos x minus sin x. Numerator there is no change, but in the denominator 1 is nothing but the sine square x. We can write sine square x plus cos square x, because we know that the sine square x plus cos square is a identity and this value is 1, and this sine 2x can be written as 2 sine x into cos x. This formula also we have learned in the trigonometry ratio. So now here what we can do, we can rewrite as cos x minus sin x, this is as it is, and here into dx, but this denominator part will become now sin x plus cos x whole square, right? Because you can see there is a terms a square plus b square plus 2ab. Now if we assume this denominator part, that is sin x plus cos x, this is equal to t, so differentiations will become cos x minus sin x and into dx. This is equal to what? So this is equal to dt. Means finally our I become integration of dt by t square and integration of t square into dt. Actually this will become minus 2 power, so integration of minus 2 means t to the power minus 1 by minus 1 plus c, and now we can write as minus 1 by t plus c. So this is equal to minus 1 upon t means sin x plus cos x, sin x plus cos x plus c. So this is the questions number 14. Now we'll move to the questions number 15. In the 15 we have given integrate tan cube 2x into sin 2x. It's again very simple questions, just we have to split the sin 3x, so we can write it as tan, so tan square 2x and then tan 2x into secant 2x as it is. Now we know the formula for the tan square 2x from identities, so it will become secant square x minus, it is 2x, secant square 2x, here one second, erase it. So it is secant square 2x minus 1 and into this tan 2x and secant 2x as it is into dx. Now we can apply the substitutions here very easily. What is that? Let secant x is equal to secant 2x is equal to t. So differentiation of the secant x is secant 2x into cot x, tan x, not cot x, secant into tan. So it is here cot should come, not tan. So secant 2x into tan into tan 2x, but by the chain rule differentiation of the 2x will come as a 2, so here I am writing 2 and then into dx, this is equal to dt. Means now our I will become, I is equal to integrations of the secant we have considered as t, so it is t square and minus 1, and here 1 by 2 will come because we have two multiples there, so 1 by t and this is dt. Means now we can integrate it very easily. 1 by 2 outside, integration of the t square is t cube by 3 minus t and plus c. Now we can replace the values 1 by 2 outside as it is, and here t means what? So t means secant, t means the secant 2x here cube divided by 3 minus secant 2x plus c. This is the answer. Now we'll move to the question number 16. So in the question number 16 we have given here 16 I is equal to integrate tan to the power 4x, tan to the power 4x. So how we can integrate it? So here 4 we have given power, so again we can reduce the power. How? So we can reduce the power, we can write it as tan square, we can write this as tan of power 2 x, and then again one more tan we can write, or we can say it is whole square into dx, right? Further what we can do, so we have, just think what we can do here, tan square, so we can apply the identity, it will become secant square, but from that can we get the answer? So tan square x whole square into dx. Okay, so what we can do, we have written in the tan square, now tan square we can replace with the secant, so we'll do that. Secant means it will become secant square minus 1 secant square x minus 1 and whole square into dx, right? So it will become now integration of the secant to the power 4 x plus 1 minus 2 times of the secant square x minus 2 times of the secant square x and bracket close into dx. So further what we can do here, 1 and 2 secant square x, answer will directly answer will come, but secant to the power 4, how we can write? Secant square, so here if we are splitting the secant to the power 4 again, then what we will get? Secant to the power 4 x plus 1 secant square integrations t, then or otherwise we will write in the different way, we can write it as we will erase it. So here what we can do, we will convert it into tan square x, and then again I will write it as tan square x into dx. I will just convert 1 in the terms of the secant, means it will become secant square x minus 1, and this tan square I will write as it is, tan square x into dx as it is. Now what we can do here, we can multiply both the things, so it will become secant square x into tan square x, and here it will become tan square x and into dx. Now what we can do, if you are putting tan x is equal to t, so differentiation of the tan x will be secant square x. Yeah, now we can do that, just we will write it as in two terms, integration of this secant square x and tan square x into dx separately, and for this part separately, tan square x into dx. Now this answer for this part will be what? Here we are going to substitute tan x is equal to t, and for the second part, here let me write one more step, secant square x and then tan square x into dx, minus this can be written as secant square minus 1. Now we can finally get the answer into dx. Here let this tan x is equal to, let tan x is equal to t, so secant square x into dx is equal to dt, right? That means here now we can write this as what? secant tan x means it is t square, right? T square into dt. And here answer of this part is what? Here actually we have like this, secant square x into dx, and this plus 1, so 1 into dx, means answer of this part is what? So answer of this is t to the power 3 by 3, and here answer of this is tan x, and here plus x. So finally we can replace the values of the t. So t is equal to tan x, means it is tan cube x by 3 minus tan x and plus x plus c. So this is the answer of the questions number 16. Now try to solve the questions number 17. So the question number 17 we have given I is equal to integrations of sine cube x plus cos cube x. Again this is very easy type of the questions, and divided by the sine square x into cos square x and into dx. What we can do here, very simple, just divide both the terms of the numerator separately with the denominator, means it will become sine cube x divided by sine square x into cos square x into dx plus this cos square x divided by sine square x into cos square x and into dx. So here this sine cube will reduce to sine x, and here cos square x, and this cos square will get completely cancelled out. The question is correct? Yes. Now this will get completely cancelled out. So what we have remaining now? We have now here sine x, and here we have cos square x. So cos square x we can write as cos x and then cos x 2 times and into dx, and here we have remaining 1 upon sine square x and into dx. So what we can do here, we can write tan x, sin x upon cos x is tan x, and reciprocal of the cos x is secant x into dx, and here reciprocal of the sine is cosecant x into dx. Now if we here we know that tan x into secant x is the integration of the secant x. It is the integration for the secant x. Integration of the secant x is tan x into secant x, and this is the integration of the cot x. Right? Here integration of the cot x is cosecant. Actually this is square, then only cot x will come with the minus sign. So minus cot x plus c. This is question number 17. Now we'll move to the question number 18. So question number 18 we have I equal to given, what is given here? So cos 2x plus 2 sine square x, and this is divided by cos square x. So what we can do here, we have to reduce the power, reduce the two multiples in the multiples of x in simple form. Like in the numerator it is 2 times of x, so we are going to reduce this. How we can do that? Cos x and cos 2x we have given. So just replace the cos 2x. Cos 2x is equal to, we know that cos 2 we can write as in terms of the sine or in terms of the cos only. So this will become 2 cos 2x we can write as, because we know the formula, since we know sine square x is equal to, or 2 sine square x is equal to 1 minus cos 2x divided by 2. So according to this formula, here it will become 2 sine square 2 sine square x, and with the minus sign, and here plus will come because we are writing the values of the cos 2x. So cos, we are taking this side, sine will become negative, so sine 2x and plus 1, and this 2 sine square x will be as it is, and divided by cos x, divided by cos x. So here it is denominator part, yes, denominator part is cos square, yeah, then only we will get the answer. It is cos square, so here also it is cos square, right? So this will get cancelled out, we have just 1 in the numerator, so we can write it as integration of minus outside, no, minus also got cancelled out, we have just 1 by cos square x into dx. That means we can write it as secant square x into dx, and secant integration we know that is tan x plus c. So the question number 18 done. Now we will move to the question number 19. Question number 19 is, we see we have given I is equal to what? I is equal to integral 1 upon sin x and cos cube x into dx. What we can do here? Very simple. Actually it is not simple, it is important, but if we understand the concept, it is very simple. So here 1 we are going to replace with the sin square x, because direct we cannot do anything. So sin square x plus cos square x, because we know the identity, right? Other all the things will be as it is, sin x cos cube x into, separately divide both the terms like this. Here we can divide the sin square x by the sin x and cos cube x, plus we can take the cos square x and divide it separately with the sin x and cos cube x, and here dx at last. Now what we can do here? Integration of the sine power will get cancelled out, means this power and this will get cancelled, and here cos square will get cancelled, this will become like this. Means now we have, or other than this we can take the cos square common from the denominator part, so that it will become the secant. So we will not cancel anything, just we are going to take 1 by cos square common from both the denominator parts. So here we can solve by this also, cancellation also, but we need to do then one extra step. So by shortcut we can do like this. If we are taking the cos x outside, so remaining will be the sin x upon cos x, and here remaining will be the, because we have taken cos x, so here there is only one cos x, right? Means here we will have one cos x and divided by sin x into dx. So now we can write it as secant square x, and this is tan x plus cot x. Now it is very simple. What we can do here in the next step, I am writing this first, tan x and cot we can write it as 1 by tan x, right? And the secant square x as it is into dx. Just let the tan x is equal to t, tan x is equal to t. So differentiation will be secant square x into dx is equal to dt. Means now I will become, I is equal to what? We can say integration is equal to t plus 1 by t into dt. Alright, now what is the integration of the t? So it is t square by 2. And what is the integration of 1 by t? So it is log t plus c. So t is equal to what? T equal to, we know that it is secant square x. So t is equal to tan x, actually t is equal to tan x. Here, so in place of the t we will write tan square x by 2 and log mod tan x plus c. Always we are writing the log in terms of mod, values in the log in terms of the mod. So this is the questions number 19. Now we'll move to the next questions, that is question number 20. So the question number 20, here we have I equal to we have given integration 1 by cos x minus alpha, or we can say a, and cos x minus b. How we can integrate it? So here again we cannot do it directly, we have to just rearrange the terms or add in the numerator. What we can do here in the numerator part, we can, because cos and cos we want to cancel, means if we apply the sine compound angle formula, we can write here sine x minus a minus of x minus b, then it is nothing but x and x is getting cancelled out, it is b minus a, means extra thing is there, that extra we will divide. Here we are multiplying and dividing, it is nothing, what we have multiplied is nothing but this is just 1, it is sine b minus a. So I multiplied and divide by the sine b minus a, and this denominator part will be as it is, x minus a into cos x minus b, and this dx as it is. Now we are going to apply the compound angle formula here, 1 by sine b minus a as it is, because this is a constant, so here we are not going to do anything. Now sine a minus b means it will become sine x minus a and then cos x minus b, and then minus here cos x minus a into sine x minus b, and this is divided by, separately we are going to divide both the terms. So here if we divide it by cos x minus a into cos x minus b, and here also we can divide it by cos x minus a cos x minus b, and then here into dx. Right, now we can cancel here, what we can cancel, so here we can cancel this cos x minus b, these two terms here we can cancel, also here we can cancel cos x minus a. So what are the remaining terms? Remaining terms we will rewrite here, 1 by sine b minus a, and here inside integration we have remaining sine x minus a, and cos means it is nothing but the tan x minus a, and here minus sine by cos means again we have tan x minus b. Now we have the tan terms only, so we can integrate it easily, this sine b minus a as it is. So here what is the integration of the tan? So integration of the tan is log secant x minus a, and this is the first term, plus, or sorry, it is minus sign, so log secant, but here it is x minus b. So here we can apply the log property, actually it is in multiplication only, 1 by sine b minus a, and here it will become log secant x minus a, and divided by secant x minus b. Right, so we can write in the terms of the cos also, but both are correct only. So this is the answer for the questions number 20. Now we have given the questions number 20. It is actually question number 22 which I solved. It is question number 22 we have skipped the question number 20. So no, 20 already I think we have done, right? 19 and 20 we have not done. Okay, so after 19 I have solved the 22. Now in the next video we will solve the remaining questions. Thank you.